Okay, so last time you learned about what inverse functions were. And I thank Dr. Yanan Su for being able to provide that information to you. Today, we want to learn how to calculate the derivative of an inverse function and find the derivative of our inverse trig function. So you learned about those in the last lecture as well. Okay, so when we talk about inverse functions, we're basically talking about a function. So we know that the function must be one-to-one, okay? And also what we call onto in order for it to be able to have an inverse. So I talk about being able, so I have a domain. So I have some domain over here, and I have some range over here. Okay, so here's my domain. So this is the domain of f of x. And this is the range of f of x. So f of x takes all of these points on one side and it goes over here. And so that's how f of x works. And we looked at how to find the inverse of a function. And then we know that the range of f of x, well, f inverse starts over here. So this is the domain of f inverse. And this is the range of f inverse. And so f inverse goes like this. Okay, so I want to talk about theorem. All right, so if a function is differentiable, so we have this function f of x going from its domain to its range, and it's differentiable everywhere on the domain that is defined, so that's an interval I, and the derivative of f is never zero.
Also, yes, I was extremely late. I will talk to you after.
I'm sorry, who's talking?
My apologies. My name is Tabahani Nick Mead. I noticed that I'm quite late to the class, but I will talk to you after class if I can about my situation. Again, my apologies for disturbing us.
Okay. All right, so if the derivative of f is never zero, then the function f inverse is also differentiable. In other words, you can find the derivative of that function. All right, so how do we do that? All right, so the first thing is we have a function, and let me see where I have done, yeah. Okay, so we have a function. So here's f of x. Oh, I didn't know it was going to do that. All right, we want to get rid of that. Don't like that. Oh, that was okay. All right. So here we have f of x, and f is going to take some point A. So I have some point over here. This is A. And f is going to grab that thing, and it's going to take it over here to f of A. Okay. Now, what's nice about that is f inverse will pick up f of A. So f inverse will pick up f of A and take it back to A. All right, so f inverse, that's the function over here, we'll pick this up and take it back to A. So we know that if we take F inverse of F of A, we get back A. So that's all well and good for the function. Here's F of X, and here's F inverse of X. So that works nice for the function. But what happens to the derivative? Well, I want to find the derivative over here. So now let's talk about F prime of A over here. So F prime of A is some value over here. All right. The question is, what is, so I know the derivative of F of A, but what is the derivative of F inverse of F of A? All right, so that's what we want to know. So over here, we want to find the derivative. Oh, I'm on black. I want to find the derivative of F inverse of the point over here, which is F of A, because F of A is over here. So now I want to find that value. Okay, so let's draw it for a minute. Okay, so I'm going to draw it. So let's draw a picture here. Oh my goodness. Okay. Okay, so here's some function f of x. So f of x may look like this. And we know that since we're replacing y with x, f inverse is exactly as if I flipped it over the line y equals x. So f inverse is this function. Okay, so this is f inverse. This is the function f inverse of x. Okay, so here I'm going to choose a point, and this point is A, f of A. So that's my point on the curve. I find A, and then I go up and find f of A. And then what point is on the other axis? Well, this point over here is going to be the point f of A, A. Remember, we switch y and x. So this one says find f of A, and then find A. Okay, so this is the value. So here's f of A. And again, here's A. Okay, so what is true is that if I know that the slope of f of x okay, at x equal to is a value, I'm going to call it m, then the slope of f inverse of x at f of A is 1 over m. Okay, so that's cool. That's how we find it. So here's the rule. If I were to draw the slope here, so here's the slope. Then the slope here is 1 over that. So this slope is 1 over that. Okay, so if the slope of the top one is 2, then the slope of the bottom one is 1/2. All right, so that gives us that the derivative. So now what we want to be able to say is, what is the derivative at f of a on the inverse function? All I need to do is find the derivative of f all I need to do is find the derivative of f of x and evaluate it at a. Okay, so if the derivative of f of x at a is m, then the derivative of the inverse at f of a is 1/m. All right, so let's see what happens here. I have a couple of examples. So the first example is nice and easy. F of x is equal to x squared. Okay. So now what I want to do is I want to find the derivative with respect to x at f inverse of 4. Now, what does that mean? Well, clearly, if I look at the function f of 2 is 4. The function is x squared. So f of 2 is 4. Okay. So f, if I want to do my little pictures again, I have f so f takes 2 to 4. That means f inverse must take 4 back to 2. Well, it does. F inverse is the square root of x. So here we have f of x is equal to x squared. And going backwards, the inverse is the square root of x. So now the question is, what is the derivative now? So now I want to know, so on this side, we want to know what the derivative with respect to x of f inverse of 4 is. Well, our formula says, okay, first find the derivative of f with respect to x. So find that first. Okay, so when I find that, the derivative of f with respect to x, well, that's easy. F prime of x is equal to 2x. All right, so f prime of x is equal to 2x. Second, evaluate it at 2, because we're on, so we need to evaluate f prime of 2. And that's going to give us some number m. So for us, f prime of 2 is 2 times 2. That equals 4. So now I know my m is 4. And then the last step says that what I want, the derivative with respect to x of F inverse at 4 has to be 1 over M. So that's 1/4. Any questions about that? Any questions? Okay, we're going to do another one. All right, so it says f of x is equal to x to the 5th plus 3. We need to find the derivative of the inverse function at 4. Okay, so I didn't give you this information, but I will give it to you now. So here we have the point one, 4 is on the curve of f of x. And the point for 1 is on the curve of f inverse of x. So this is asking me, so again, we go from the point 1 over here to the point 4 over here. So f takes 1 to 4, and f inverse takes 4 back to 1. So this is f, and this is f inverse. So now I want the derivative of f of inverse. So what we're trying to find is the derivative of the f inverse function at 4. Okay, so what are our steps? The first is to find the derivative of our original function. And that turns out to be 5x to the 4th. Then we need to evaluate it at 1. So remember, f only acts on this side. F only acts over here. So we need to evaluate the derivative at 1, and that just becomes 5. So that's our m. So therefore, the last step is the derivative of our inverse function at 4 has to be 1 over m. So that's 1/5. Okay, any questions about either of those two topics thus far? Okay, so that's how we find the inverse. All right, so we know that the derivative of the inverse function, which is in set B, happens to, so we call these A and B. Then we just need to find what the derivative of 1 is, and then take 1 over that. All right. Let me see. I don't see any questions. Everybody seems to be okay. In fact, y'all look bored, so let's keep it moving. Cool. I like that bored look. That's all right with me, because that means I think that's too many examples. We're gonna keep it moving. Okay. Here's where life can get a little bit more interesting. These are the derivative of our inverse trig functions. So you learned in the last section that if the sine function, you can take the sine of a function, of a variable, and then its inverse function is the sine inverse, or some people call it arc sine, arc tan, arc secant, arc cosine, arc, this should be cotangent. Okay, so that should be cotangent and then cosecant. That is correct now. Okay, so these are the derivatives. So if you want to take the derivative of the sine function, you just get cosine. But if I want to take the derivative of the sine inverse function, that's a little bit different. That is 1 divided by the square root of 1 minus x squared. The derivative of the tangent function is 1 over 1 plus x squared, nice and easy. And the derivative of the secant function is 1 over the absolute value of x, the square root of x squared minus 1. And just like our regular sine, cosine, sine, cosine, tangent, cotangent, secant, cosecant, trig functions, the derivative of the cos is negative. All right, so you just have to only really worry about knowing the first 3. So if you know these over here, if you know sine, derivative of sine inverse, tan inverse, and secant inverse, then you automatically know the derivative of cosine inverse, cotangent, and cosecant. Now, these are not going to go away. These are functions are going to be with us for the rest of the semester. So I need you to make sure that you learn these and memorize these, commit these to memory, and be able to utilize them, because you will see these on an exam inside of other problems. Okay. So I have 2 examples I want to do. It always helps if I do an example. So
can you back up a little bit, please?
I certainly can. You mean to hear?
Yes.
No problem. Okay. So example 1 is to find, we want to find the derivative of x cubed times the tan inverse of x. Okay, so for number 1, f prime, what kind of rule am I going to use to do this problem? This is actually an easy one. So I'm just going to use the product rule. Okay, so it's the derivative of the first, which is 3x squared, times the second, which is tan inverse of x, plus the first, which is x cubed, times the derivative of the second, which is 1 over 1 plus x squared. Nice and simple. Any questions? Okay, number 2, we want to find f prime. Again, I'm going to use the product rule. So I'm going to take the derivative of the sine, cosine of x, and then multiply it by sine inverse of x. Then I'm going to take the first, which is the sine of x, and multiply it by the derivative of the second, which is 1 over the square root of 1 minus x squared. Okay, any questions? Okay, so those are the easy ones. We can do the same thing with the secant function, the cosine inverse function. All of them are roughly the same. Okay, so now let's consider the fact that u of x is a function of x. Okay, so now we're not, don't just have x, we now have u of x. All right, so now we have to invoke the chain rule. So is there anybody that needs a quick refresher on the chain rule? Please say so or type it in the chat now.
I do.
All
I
righty.
do.
All righty. Thank you. I appreciate the honesty. I love it. Okay, so let's do a little bit with the chain rule. Okay. All right, so let's talk about the chain rule for a moment. Okay, so we want to say y is a function of x. Then in order to find dy dx, you have to find the derivative of y with respect to u times the derivative of u with respect to x. So what does that mean? So here we go. So y is the sine of x squared. Okay, so y is the sine of x squared. So if it was just y is equal to sine of x, the derivative would be cosine x. Okay, so we're going to let the inside function be u. So I'm going to let the inside function be u. All right, so now I'm going to let u be x squared. So that's the inside function. And then the outside function says y then becomes the sine of u. Does everybody see that? So if I let this inside function be u, then really I have y is equal to the sine of u, where u is equal to x squared. Is that clear? For those of you who weren't quite sure, is that clear?
Yes.
Okay. All right, so now we need to find the derivative of y with respect to u. So y is sine of u. So what is the derivative of y with respect to u? Hello? What's the derivative of the sine of u? Oh my.
Is it just cosine of u?
Yes, it is. It's the cosine of u. Okay, so that part is done. And then what is the derivative of u with respect to x? Take the derivative of u with respect to x, and what do you get?
2x.
2x. Awesome. Okay, so we're done. So the derivative of u with respect to x is 2x. So therefore, dy dx is the cosine of u times 2. I'm sorry, I'm writing it. I'm gonna put it all together. Is dy du times du dx. Dy du is just cosine of u, and du dx is just 2x. And we normally put everything in front of the trig functions. So that becomes 2x, but the cosine of u, I gave you the problem in x, I want it back in x. So the cosine of u becomes the cosine of x squared. So that's the chain rule. Do we need another example? Are you guys okay?
Can you do another example, please?
I certainly can. Okay, so let's say y is equal to 1 plus 6x squared to the 7th power. Okay. Again, I'm going to take the stuff on the inside and I'm going to call that u. So now I'm going to let u equal 1 plus 6x squared. And then that means y looks like u to the 7th power. So now I need to find dy du. What is that? That says take the derivative of y with respect to u. What do you get? Just use the power rule. Anybody?
7x to the 6.
Okay, actually 7u to the 6th.
Yeah, yeah.
That's correct. Good.
7u.
I got you. 7u to the 6th. Very good. All right. And what is the derivative of u with respect to x?
$12x.
12x. So now we put it all together. The derivative of y with respect to x is the derivative of y with respect to u times du dx. So that's going to be the derivative of y with respect to u is 7u to the 6th power. And then I'm going to multiply that by du dx, which is 12x. So now this becomes 12 times 7, 84. I still have an x. And u to the 6th, what is u? U is 1 plus 6x squared to the 6th power. So I have to make sure I put my u back in, just like I did over here. I put my u back in. Okay. So that's how the chain rule works. So now we can do the chain rule with inverse trig functions. So let's see, here's one, the derivative of the sine inverse of u of x. So the y here, is the sine inverse of u. So therefore, when I take the derivative of this, here's the derivative. So notice this thing right here, this piece right here, that is the derivative of the sine inverse. And then we still multiply by the other piece, which is the du dx. Okay. So I have a couple problems here. The first one, when using the chain rule, so the sine inverse of x squared plus 6. So if you want to do it the way I did the other problems without using the formula, but you want to just do it the other way, you have y is equal to the sine inverse of x squared plus 6. So therefore u is equal to x squared plus 6, and y is the sine inverse of u. So now I need the derivative of that. So the derivative of y with respect to u, the sine inverse of u is literally just 1 over the square root . Why is always crooked? Of 1 minus u squared. And then du dx is simply 2x. So therefore, dy dx says take the 1 over the square root of 1 minus u is x squared plus 6, and then multiply by du dx, which is a 2x. So my answer is 2x divided by the square root of 1 minus x squared plus 6. And this should be squared. Squared. Okay. All right, any questions about that? All right, I'm going to let you try number 2 on your own. So y is equal to the tan inverse of the sine of x. And I'm going to remind you that if y is equal to the tan inverse of u, then dy dx, I'm sorry, dy du is equal to 1 over 1 plus u squared. Okay, so you will need that to do that problem. Okay, so I'm gonna let you work on that for a few minutes. Okay, anybody have an idea of how to attack that problem?
So would u equal sine x,
Okay, so u is going to equal sine x.
and then du dx equals cosine x.
So that's cosine x. All right, so now what do I do?
So then dy dx equals du over, well, I could just, you want me to just say the answer or?
Yes, tell me what you got.
Oh, okay, I'll keep going. Dy over du times du dx. And then so 1 over 1 plus u squared times sine x, wait, times cosine x, sorry.
So I get 1 over 1 plus u squared, you said?
Yes,
Okay, times.
cosine x.
Okay, and can you simplify that to the final answer?
Cosine x over 1 plus sine x squared.
Perfect. Any questions? Okay, one more, it's pretty nasty. The secant inverse of 2x over x cubed minus 1. So what rule do I need to use here?
Is it the quotient rule?
I need to use the quotient rule. Okay, so quotient rule, there are many ways we can do it. So we can say, a lot of people say it's low D high minus high D low over low low. I've heard that. I've heard bottom times derivative of the top minus the top times the derivative of the bottom over the bottom squared. There's so many different ways to state the quotient rule. Okay, so let's see, y prime is going to be the bottom, which is x cubed plus 1 times the derivative of the top. So the derivative of the top requires us to do a chain rule. All right, so we need in here the derivative with respect to x of the secant inverse of 2x. Okay, minus the top times the derivative of the bottom over the bottom squared. Okay, all right, so now what we need to do is we need to do that derivative of the secant squared of 2x. All right, so let's see what that is. The derivative of the secant, I don't mean squared, I mean secant inverse of 2x. Okay, so what's the outside function? The outside function is secant inverse of something, of u. All right, so we need to take the derivative of that. So if u is x squared, then I need to take the derivative of this, and that becomes 1 over the absolute value of u times the square root of u squared minus 1. So I know I'm going to have that part. That's the derivative of the secant of u part. And then I have to multiply by the du dx part. So that's the 2x part. So therefore, this becomes 2x over the absolute value of, I'm sorry, the derivative of, this is 2, not 2x. So that becomes 2 over the absolute value of 2x times the square root of 2x squared minus 1. Okay, so our final answer, which is still not going to be cute, but at least we know we're going to get a final answer here. When we put it together, is that our y prime is x cubed plus 1. I'm going to cancel the 2's, so I'm just going to get 1 over the absolute value of x times the square root of 4x squared minus 1. And then I'm going to get minus, I think I forgot something. 3x squared, the derivative of the bottom times the top. I forgot to put the top in here. Secant inverse of 2x. Bottom times the top minus the top times the derivative of the bottom over the bottom squared, right? So minus 3x secant inverse of 2x, and all of that is over x cubed plus 1 squared. Okay. Last one's tricky, but I want you to do it. Okay, let's do a review of the last two sections.
Wait,
Okay.
can you go back up, please?
Can I go back up?
Yeah.
Absolutely.
Okay, I got it.
Got it. Okay. Everybody else okay with this?
Yes.
Okay.
Yeah.
All right. So here's some review questions. So here's a function defined for x greater than 9. So x cannot be 9. Find the inverse of the function. Okay, so I want you, so what are the steps to find the inverse of the function? Now, I think I look back at the notes from Dr. Zhu, and she actually does it a little bit different than I do, which is okay. I like to switch the variables first. I think she switched them last. So, but it's either way, it doesn't matter. So what I normally do for problem 1, so let's, for problem 1, my steps are to first write switch x with y. Okay, so I switch x and y. That's what I do first. My second step is then I solve for y. And then my last step is to find the y to actually be the inverse function. Uh-oh, that didn't write right. You didn't do what I want you to do. Yeah. I don't even know where my notes went. Okay. Okay. All right. So here's our problem. We have y is equal to the square root of x divided by the square root of x minus 3. Okay, we're not going to get a chance to finish the review, but I will send it to you guys and you can practice the review. Okay, so that's the first step. The second step is to switch them. So now I want x to be the square root of y divided by the square root of y minus 3. And then now solve for y. Okay, so this is going to take a little bit of algebra. So I have, the first thing I'm going to do is multiply by square root of y minus 3. So I'm going to get x times the square root of y minus 3 is equal to the square root of y. So now I have x times the square root of y minus 3x is equal to the square root of y. Okay, what am I going to do next?
Wouldn't you divide by the square root of y?
I would like to, if I divide by the square root of y, I'm going to end up with the square root of y in the denominator, and I'm going to have it in that one term with the minus 3x. So that would help, but I think it might help even better if I put them both on the same side. So if I have x minus 1, x times the square root of y minus the square root of y, and then I'm gonna put the 3x on this side. So now I'm going to factor out the square root of y, and that's going to be times x minus 1 is going to be equal to 3x. So now I can divide and get the square root of y is equal to 3x divided by x minus 1. And so when I square both sides, I get y. It's going to be 9x squared divided by x minus 1 squared. Okay. Any questions? So now the last step is that f inverse now of x has to be 9x squared divided by x minus 1 squared. Okay, so here's a question, and I'll bring that back again. Find the domain and range of f inverse. The domain and range of f inverse. So what's always the most difficult one to find? What's the most difficult one to find? The domain or the range?
The domain.
Okay, so how do you find the domain of a function? You look to see all the values of x or y that you can put in the function, right? And then the ones that don't work, don't work. Okay, so the domain, if we go back and look at this problem here, the domain, actually, I'm just going to make this even easier and say x is not equal to 9. I'll make that even easier. I don't know how to do. There we go. Perfect. We'll make it x is not equal to 9. So anything else can go in the function except for 9. Okay, so now remember that the domain of f is the range of f inverse, and the range of f inverse, the range of f is equal to the domain of f inverse. So if I go back and look at this, and I see that from here, x cannot be equal to 9, I know the domain of f is the set of all x such that x cannot equal 9. So right away, that tells me that the range of F inverse is the set of all x such that x is not equal to 9. And then if I look at F inverse, what number can I not put in F inverse? Here's F inverse. What can I not put in F inverse?
With the x minus
Nine.
1 squared.
I can't put in 1. Excellent. So therefore, I can just look at that and say that the domain then of F inverse is equal to the set of all x such that x is not equal to 1. So I normally never find the range of anything. I look at the domain of F. That lets me know the range of F inverse. I look at the domain of F inverse. That lets me know the range of F. Okay. All right. The next part of the review. Aha. So given F of X is equal to, so here's the problem. So I have a function, F of X is 2x cubed plus 1 cubed. And the point 127 is on the curve. So again, I have one and I have the other. So here is the point 1 is over here and it goes to 27 over here. 27 is one of my favorite numbers. Okay, so F takes 1 to 27 and F inverse takes 27 back to 1. So now I want the derivative over here of F inverse of 27. What do I need to do? We have 1 minute. What do I need to do? This is actually rather easy.
Is it 1?
How'd you get 1?
Because it starts off at 1 and 1 goes over, turns into 27.
Okay, so that's the inverse of 27. That's a very good answer. That's the inverse of 27. What we need is the derivative of the inverse of 27. And so we have a cliffhanger because it is 1:15. I will see you guys tomorrow. Okay. Have a blessed day.
You too.
Thank you, you too.
You're welcome.